Welcome to Module 4, Lesson 3. So, before jumping into the lesson, I will be using a ruler to measure out many of the things I'm going to be doing. I'm going to be using both sides of the ruler. I'll be using the inches, which is the one that's spaced out more, 1 to 12. And I'm also going to be using the other side, which is the one that has a whole bunch of little bitty teeny tiny marks that goes 1 to 30, or 30 over there. So just kind of keep it in mind while I'm doing this. So, why is this important? Well, let's talk about it. So, I can model tiling with centimeters and inches, inch unit squares as a strategy to measure area. So, going off of that, this is a 1 foot, or it's 30 centimeters as well. And so 30 centimeters is equal to 12 inches because they're on the same level, they end at the same point, etc., etc., etc. So, that being said, you can look here and recognize that 1 inch is that long, from here to my other finger. That's 1 inch. A 1 centimeter is that big. So you can see a centimeter is much smaller. So before going into this, I just want to show you guys an example here. I have a 1 by 10 a square shape here in inches and centimeters. So you can tell this by going, well, just like you would do with an array, how many deep is it? There's 1, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's 10 across. So 1 times 10 would be 10, or since we're doing area, it would be 10 square inches since I'm in inches here. Now, down here, it's a lot smaller, but it is still only 1 wide, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 also, but it's centimeters. Well, this one up here is in inches. So the quick question here is, the answer to both of these is 10. But which one's bigger? Well, just off the number, you might be tempted to say, well, they're the exact same. 10 and 10, 10 equals 10, right? Well, remember that. Does 10 minutes equal the same as 10 hours? No, hours are way bigger, so hours would be considered the bigger unit. That is a similar process being portrayed here. Inches are bigger. So 10 inches is larger than 10 centimeters. Keep that in mind. Usually we go back and forth between measuring in inches and centimeters for this lesson, but for the purposes of you not having to count little circles this big on your screen, we're going to do all of them in inches, at least here, just so you can see them without it being too teeny tiny for you. So just kind of keep that in mind. So I'm going to go ahead and stick with this 1 by 10 area. And remember, area is how many blocks, or how many basically squares, since we're talking about square units. So how many of these square units does it take to cover this entire thing? And we already found that out. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or one group of 10. Now, hypothetically, if I doubled that, like this, then I would have 2 rows of 10, which means the area with this would be 20 square inches. And SQ is just short for square. Just kind of keep that in mind, is that it kind of goes exactly like an array. You just kind of go down the line, multiply both sides by each other. So, but we are only going to stick with 1 row right now. And we kind of hit on this a little bit in the last session, but I'm going to give a reminder. Just because a shape looks different does not mean that it is a different area. So, if it has 10 squares, it has an area of 12 square centimeters, which means anything that has 10 square centimeters has the same area. So, going off of that, using the same idea of arrays, what 2 numbers multiplied together equal 10? So, you can go down the line. 1 times 10. That's 1. We already got that one. Let's try 2. Does 2 times anything equal 10? Let's try. Skip count by 2 until we get to 10 or near 10 to determine if we're right or not. So 2, 4, 6, 8, 10. So that one works. So we have 2, and since I ended on 5, 2 by 5. So I'm going to make it 2. So 2, 3, 4. I'm going to make it a little shorter to make it a little accurate. You know what? Actually, I was going to use the ruler, so I don't know why I'm not using it. This actually measure out 10 inches. Since I'm in the same unit up here, I'm going to measure 5 across, so 0 to 5. Right there. I'm going to measure 1 down on both sides to ensure that I'm measuring it properly. Yeah, I did erase just a tad there, but I'm going to go ahead and go down. But oh wait, I just remembered. I actually need 2 inches down because it's 2 on that side. So go ahead, finish that off. And I'm just going to hold this up right here, and whenever it says 1, 2, 3, or 4, I'm just going to go ahead and draw as straight of a line straight up as I can. Once again, there will be human error in this, just due because, well, I'm human. Drawing a straight line sometimes can be a little tricky. But now I have a 1, 2 by 1, 2, 3, 4, 5 area. And if I count all these up, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 2 by 5, which is 2 times 5, which is 2 times 5, which is 10. So this has a area of 10 square inches, and this shape up here also has 10 square inches. So which one's bigger? Which one's bigger? Now, there's a couple things you might say. You might say, well, this one's bigger because it's longer. Or you might say this one's bigger because it's wider or taller. Now, remember what I said. If it has the same amount of squares in it, it's the same amount if it's in the same unit. And since these are both in square units, square inches, if this is 10 and this is 10, they're the same. So if these are both 10, that means they both are the same. They have the same area. They're both covering the same amount of space. Now, there's not a whole lot more you can do this one, but you could technically, I'm going to kind of shorthand this one, make it 10 long, 2, 3, 4, 5, 6, 7, 8, 9, so much. 6, 7, 8, 9, 10. Once again, not perfectly to scale, but a 10 by 1 or a 5 by 2. 1, 2, 3, 4, 5. Just making sure you got it right. Technically, it's the same thing. Commutative property. You turn this picture sideways, you get another multiplication set. But let's do one more, just kind of give you another example of this. We'll use one that's a little bit different. I'm going to use my trusty measuring stick again. Take my marker cap off. We're going to make it 6 long, 2 tall, and make sure I mark that on both sides. Right, here we go. And then at the bottom line right there. And at the 1, draw a line. At the 2, draw a line. At the 3, draw a line. At the 4, and the 5. And then, cut it in half that way. Once again, human error. Lines not be perfectly straight, but for the purpose of this, they're perfectly the same. Every single one of these squares is the exact same size. Is it really? No. But for the purposes of this lesson, they are. So there's 1, 2 down this way, and 1, 2, 3, 4, 5, 6 across. Do this the exact same thing as an array. Solve this by going 2 times 6 equals 12. Since we're in inches, is square inches. So the question here is, what other shapes can you use to potentially get 12 square inches? Because there's a lot of different shapes for this one. A lot of different shapes that you can create to have the same outcome. Now, commutatively, we already know one. If I know that 2 by 6, or 2 times 6 equals 12, swap them. So if you know this one, you will automatically know that you have this. So 2, 3, 4, 5, 6. All right, there you go. You have 6 by 2. So now you have, oops, equal sign, whoopsies, struggling today a little bit. 6 times 2 equals 12 square inches. Now, is that all the potential answers we have? What else can there be? Now, I will say if you are a little rough around your edges with your math facts, there's another strategy you can do here. You know your total's 12. So do this. At the bottom of your page or on another piece of paper, just write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 at the bottom of your page. Now, you just need to go down the line and go, okay, does this number, anything by this number equal 12? And you can do that. So 1. 1 times anything will equal 12. And you can do it. So 1, 2, 3, 4, 5, 6, 7, 8. You figure it out. What 1 times what equals 12? Well, 12. So there's 1. So you could go ahead and create that. 1 by, when I kind of hand draw this one again, 12. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. So you have a 1 by 12, which would equal 12 square units, or inches, since the unit is inches. Which means, once again, you could flip it. You could do 12 by 1 and just have a very long one that goes all the way like this. So 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Assuming that they're all the exact same size, exact same shape. Once again, human error now. So that one works. And if we know that 1 times 12, that means know that the 12 works too. So those work. Sweet, awesome, wonderful. Now, does 2 work? Well, we already found out it does. So 2 works, and found out that 6 works with it as well. And so 6 and 2 right there, we're good on both of those ones. Now let's go down the line. There's 3. Does 3 times anything equal 12? Well, let's count. Let's get count by 3 with me. And if it doesn't hit on 12, it doesn't work. So if it like hits 11 or hits 13, it doesn't work. It has to hit on 12. So 3, 6, 9, 12. So 3 times what equals 12? 3 times 4. So I can create another one. So make it 3 by 4. So, and then, once again, I'm running out of room here a little bit, but you turn it sideways, and then you have a 4 by 3, and that has the same area. So we know 3 and 4 work as well. Now, 5, does 5 times anything equal 12? Well, let's skip count. 5, 10, 15. All right, so did we hit 12? No. Did we go over 12? Yes. And so the closest one's 10, but is 10 12? No. So 5 doesn't work. And now here's a little secret as well. 6 is halfway to 12, right? So 6 times 2 is 12. Which means any number above that has to be times by a number smaller than 2 in order to get to 12, right? Well, 7 times 1 isn't going to get there. 8 times anything? No, because it goes, like 7 goes 7, 14, too high. 8, 16, too high. 9, 18, too high. So we know none of these are going to work because just due to the fact that doubling them will make it too high. Can I keep that in mind? So going off that, I'll draw one more right here to represent the 4 by 3. And now, assuming every single one of these squares is the exact same size, once again, human error here, every single one of these covers the exact area perfectly. This one has 12 square units, 12 square units, or since we're in inches, so 12 square inches, 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 12 square inches. So even though they all look different, they all have the same area. Now that's kind of the main thing you need to do here, is recognize when they do. Now, if I had a shape over here, I'm doing a different marker so you can see it, that was, let's say, a 2 by 4. Or you could say that's 2 by 4, so the total is 2 times 4, which is 8. Does this have the same area as the ones over here? No, it doesn't, because it's 8. It has a smaller area. It's 4 less than one needs to. You actually need it. If you wanted to, you could make one more group and you'll get this one over here. So that's kind of the main idea here, is recognizing that using the same idea as arrays, you're trying to determine if it has the same ending, if it has the same amount of squares, you're good. They have the same area. But if they don't have the same amounts, well, it's different at that point. It's a different area. So keep that in mind. Your homework, recognize, do they have the same area or do they not? But please remember, if they have a different look or a different shape, that doesn't necessarily mean that they're not the same area. Do the math on that. So just kind of keep that in mind. So hopefully this was helpful. I hope you guys have a great rest of your day.